Alright, so today I'm going to be showing how to use long division to be able to integrate rational functions. So we have this function over here, and we want to try and integrate it, and it's not in the form of easy to integrate. It's not easy to integrate. So we're going to try and do some long division to be able to write these in terms of something we can easily integrate. And so let's divide them like they're divided. And we're going to try and write this in terms of it's something we can divide. So we're going to draw this division thing, and we're going to do some long division. So x plus 3 is on the top, so it goes on the inside. And so then we have x plus 4. And so then we have what goes into... Alright, so what times x will give us x? That is 1. So we know that 1 will be up here. Okay, so then we're going to have to subtract something. So we're going to put a minus sign and some parentheses because we're going to subtract everything. So we're going to know that this is going to be x because we're going to subtract this. Now we're going to do 4 because here times this, and so that is what we're subtracting. So we're going to add 4, and so when we subtract these things together, we get left with a negative 1. And so now we can say that this integral expression is the same thing as 1, which is where this came from because we divided these and get 1, except we have a little bit of a remainder. We have this negative 1 over the denominator remainder. So we can then subtract 1 over the denominator. And then we're integrating with respect to x again. So because when you divide this number by this number, you have 1, and then we have this little bit left over. And so now we can actually integrate this. We can use our power rule and some properties of integrals. So we know that the integral of 1 with respect to x is 1. And then we know that when you integrate something like this, when it's 1 over something, it's just going to be the natural log of that. So we're going to subtract the natural log of x plus 4. And that is it. And don't forget your constant of integration. Plus, let's actually draw a good plus. Plus c, and that is it. We can box our answer. Done. Alright, so now we're going to try and integrate this, I forgot to put the dx, with respect to x. And so, again, this is not really in a form we could easily integrate, so we're going to do some polynomial division. And so x plus 2 is on the denominator, so we're going to have x plus 2 on the outside. Alright. And then what goes inside this division, we have x squared. Now, we're going to write plus 0x because it's going to be easier to just kind of remember your terms. And then we have 0 plus 3. So if you skip a power, you just want to write 0 and that power because it's the same thing, but you just so you can help keep your place. So what times x will give you x squared? That is x, and so we're going to put that over the x squared because x times x will give you x times x will give you x squared. And so we have that. And so now we can start our first layer of subtraction. So we're going to subtract and then some parentheses. We may not need all of it, but we're still going to write it. And so we know that this will always be, when you subtract it, it will always leave 0. So we're going to write x squared because this times this will give you x squared. And next, we're going to say 2 times x. So we're going to, because that's this term right here. So we're going to say 2 times this x. So this is not, that is not a 2, 2x. And there is another term, so we don't actually have to subtract here, or we don't have to put something in this little spot right there. So now we can actually subtract. And so this is just, I'll do that in red. This just leaves 0, so we don't have to worry about that. But we now have 0x minus 2x, which is negative 2x. And then we have 3 minus nothing, which is just 3. So positive 3. But we still can't properly integrate this, so we're going to have to go again. So we're going to say what times x will give negative 2x, and that is negative 2. So negative 2. And so we're going to subtract this, and so we know this is negative 2x. And so now we're going to say, we're going to look at this term and say what is 2 times negative 2, and that is negative 4. So we're going to do negative 4. And so whenever we subtract these negative 2x's will cancel. And now let's look at this side over here. So we're going to have 3 minus a negative 4. So that's actually 3 plus 4, and which is 7. So now we have this x minus 2 as a front term, and then we have 7 over the denominator, and we can integrate that. So let's rewrite this integral. And so we have this, we could, when we divided it, is pulled out. So we have x minus 2, and then we have 7 over the denominator, because we couldn't divide that. So we have now plus 7, and then we're going to say over, and then x plus 2. So x plus 2 dx. Okay, so now we can integrate this, because we know that the integral of x with respect to x is x squared over 2. That's just the power rule for integration. And then the same thing for the 2, we can just add on to the exponent and divide by that exponent, which is just 1. And then we know that this, if you tried to integrate this, is just the constant up top, because it's just a regular number. So 7 times the natural log of what's underneath. So x plus 2. And then we got the plus c. And that is it. We can now box our answer. Alright, so we're going to do a couple more of these problems. And so we could do long division again if we wanted to, or we could do synthetic division, which we can actually do because this bottom term is it is a binomial, and we can do synthetic division with binomials, which is pretty cool. And so I'm going to show you how to do synthetic division, because it's similar to long division, but we can kind of save a bit of that time just doing all that excess subtraction. So we're going to draw a reverse division sign. And so we look at this term here. We have a we have our binomial here, and so we're basically going to set it equal to 0 and find the 0. And so the 0, x minus 5, is equal to 0, add 5 to both sides, is equal to 0, or is equal to 5. So we have 5 is our fancy number over here. And so we're going to look at the coefficients of each of these terms, and we're going to write them down. So we have 4, negative 12, and negative 25. And so back in the days of Algebra 2 and pre-cal, I guess, is when you would have done this. You would be trying to find where you can divide it, and it would be an even. It would be even, and it's not necessarily even here, because we are probably going to have some ln's. And so how you do synthetic division is you bring this first number down. And so we have 4. And then we're going to multiply these numbers. And so 5 times 4 is 20. And then when you add it, then you're going to add each of these columns instead of subtracting like in long division. So this is going to be an 8. And so then 5 times 8 is 40, leaving positive 15. And so we're going to, I'm going to just kind of like circle this, but it's not our answer, just so we can remember this in just a second. Because this is our remainder. Because if we divided this, we would have 4x plus 8. And then this would be our remainder over the thing, over this denominator here. And so we're going to write that. Because now it's in the form we can integrate, right? Because we have this stuff that actually was able to be divided. So we have 4x plus 8. And then we have this plus 15. Plus 15. I'm going to pull up the 15 because we're going to divide it by our denominator. And our denominator is x minus 5. X minus 5 dx. Right? And so now we can integrate this using our fancy rules for integration. So adding 1 to the exponent gives us x squared, and then divided by that exponent leaves 2x squared. And then we can just say 8x. And then here, this is just a constant on top of this. And so we could just say ln of x minus 5, because that is the denominator. And then we can't forget our constant of integration. And that is the answer. Boom. Alright, so this problem is kind of interesting. So let's look at this. So again, this is not in a form where we can easily integrate it. So let's do some long division. So we have x squared plus x plus 0. And then, because this is not a x plus some number, we cannot do synthetic division here. So we're going to now have x squared minus x plus 1. Alright, so we're going to see what times x squared will give us x squared, which is just 1. So we get to save some steps over here, which is pretty cool. So now we have x squared times 1. And then we're going to say now x times 1 is just x. So plus x, and 0 times 1 is 0. so plus 0. And so we're going to subtract these, and this will cancel, say 0. And so then we're going to say negative x minus positive x. So that's just negative x minus x, which is negative 2x. So negative 2x. And then 1 minus 0 is just 1. So now we have this over our, it's 1. Now we have this over our denominator. And so I will write this down. So we have the integral of 1 plus this part. So we're gonna say, so I'm actually gonna leave it like this: 2x plus 1 over, and then I'm gonna write x. And now we realize we still can't integrate this, but we can't divide it any further either. So what do? We can use another concept. We can do our partial fraction mess. So we can factor out an x out of this x squared plus x. And so the partial fraction, I'm going to do this in a different color, says that we can write this a over the first factor, and so this first factor is x. So x plus b over the other factor, which is x plus 1. X plus 1. And so we're going to basically solve for these values of a and b. And so we know that somehow this must be equal to this. And so we're going to have negative 2x plus 1 is going to be equal to x times x plus 1. X plus 1. And so now the best way to try and solve for these values is using a common denominator. So we're going to multiply everything by x times x plus 1. And so whenever we do that, this will cancel, and a will be multiplied by x plus 1. So x plus 1, because when you multiply by x times x plus 1, this x will cancel. And then when we multiply this by x plus 1 times x, this will cancel, and so it's just bx. And so now, because the constants, they are constant values for no matter what we set, we can choose any value and just solve. We can choose any value for x and then solve for that constant. And so we want to make one of these terms be 0. So we could say, for example, x is going to be equal to 0, right? So if x is equal to 0, right? So if x is equal to 0, this b term is also 0. And so we have a times 0 plus 1, which is just 1, is going to be equal to 0 plus 1. And so now we have solved for this a value. This whatever is over x is actually 1. So we know, so a is going to be equal to 1. A is equal to 1. And then we can do the same thing for b. Instead, what will make the a term equal to 0 is negative 1, because x minus, or negative 1 plus 1 is 0. So we're going to let x be equal to negative 1, and then we're going to now solve. And so we now have 0 times, or 0 plus negative 1 times b, so that's negative 1b, is going to be equal to, now we have to substitute it in over here. So we're going to say negative 2 times negative 1 is positive 2, and then plus 1, which is 3. And so b is equal to negative 3. I assume you guys could kind of see this algebra here, right? So we have now a is equal to 1 and b is equal to negative 3. And so now I'm going to do this part in a different color. But now we can rewrite this in terms of this, in terms of our partial fractions, which we can integrate like we saw before, but with a and b. And so we now have our integral of 1 plus a over this, and a is 1, so we're just going to say 1 over x, and then we're going to do the other term, so b over x plus 1, and b is negative 3, so we're going to do minus 3 over x plus 1, x plus 1. And then we're going to do this with respect to dx. And so we can, when we integrate this, we have integrating 1, we have x and then we have the integral of 1 over x is ln x by definition. And then we have 3, because this is this number on top, times the natural log of what's on the denominator, so x plus 1. And then plus c. And it was quite a bit of work, but it is not very complicated. Boom, boom, boom. And we're done. Alright, so now we're going to do one more of these, and then we're going to do some of that with u sub. So we already know that we can't really integrate this with our normal techniques. So we have our, we're going to do some long division first. We have our denominator on the outside for x minus 5. And then we have our numerator on the inside for x squared minus 5x minus 15. And so now we're going to do long division. And so we look at this and this. To get from x squared to 4x, we multiply by 4. And so we put it over our constant because it's a constant term. And so now we can start our subtraction. So we have now 4x squared. We already know that this should cancel. And so now we're going to say negative 4x times 4, which is going to be positive, negative 4, negative 16x, negative 16x. And then negative 5 times positive 4 is negative 20. And we can subtract this. And so these will cancel. Negative 5 minus 16x, that's the same as adding 16x. And so that will be 11x. And so then 20, positive 20 minus 15 is going to be equal to 5, because we know this is positive and we're just subtracting the 15 up here. And so we can't divide anymore because we are out of terms. So this, like the last term, or like the last question, we're going to have to do some partial fractions stuff. So let's do this in green. So we're going to have the integral of 4 plus a over what? So we have the denominator, but it's not actually factored. So let's go up here and factor in yellow. So we have, let's do, what are the factors of 5? 5 and 1. So the negative is stronger here. So we're going to subtract 5 and add 1 here, x plus 1. Because we know that when this multiplies out, this will be negative 5, and this negative 5 plus 1 is negative 4 in the middle. And so we now have a over x minus 5, x minus 5, and then we're going to have plus b over x plus 1. And then we're going to do that with respect to dx. And so now we have to find these values of a and b. And so, like before, yeah, I'll do this still in green. So we're going to now set a over x minus 5 plus b over x plus 1, and we're going to set that equal to the whole thing, which is going to be 4x squared minus 5x minus 15 over our denominator. And so I'm just going to write it in yellow because I can. And that looks like, I don't even know what that looks like. X minus 5 times x plus 1. And so we know when we multiply these, we're going to basically cancel out this whole bottom term on the right. And then we're going to have a times, when you multiply this by both of these terms, we're going to get the x minus 5's will cancel on this side, or on the a term. And so we now have x plus 1, and then b times x minus 5. And so we want these values to be 0. And so we're going to say, what other color do I have? I don't want to do it in red. Green. So we're going to solve for, I guess, we're going to substitute in here. So let x equal to negative 1, so that this a term right here is 0. And so now when x is equal to negative 1, we know that b times negative 1 minus 5 is negative 6. So negative 6b is going to be equal to 4 and then we're going to have minus, actually it's going to be plus because it's a negative 1, so plus 5 minus 15. And so that does not look like a 5. And neither does that. 15. There we go. So 9 minus 15 is 6, or is negative 6. So b is going to be equal to positive 1, because negative 6 is going to be equal to negative 6b. So the term over x plus 1 is going to be 1. So b is equal to 1. And then we will do the same thing for x is equal to 5. So we're going to say 6a is because 5 plus 1 is going to be equal to 25 minus 5, which is this 0. And so that's going to be, wait, did I do that right? Oh, 4 times 25. So that's going to be 4 times 25 minus 25 is going to be 50 minus 15. So here we go. 4 times, let me think, 4 times 5 times 5, 100. Let's not skip steps. Let's not skip steps. That will lead to math errors. Minus 5 times 5, 25. Minus 15. Here we go. That is 60. 60 is equal to 6a. 6a. And a is going to be equal to, I nearly wrote 6. It is 10. There we go. And so now we have our values for a and b. And so now this integral is basically right. We just have to substitute in our values for a and b. So 4 plus, now 4 plus 1 over x minus 5. And then it's 4 over, oh wait, a is 10. So x minus 5, we're going to do 10. There we go. And then we're going to add this to 1 over x plus 1. And then dx. And so when we take the antiderivative, or we integrate it, we get 4x by the power rule, and then 10 ln of the denominator, so x minus 5, then plus 1 times the natural log, so it's just ln of x plus 1, x plus 1, and our constant of integration, so plus c. And that is our answer. Boom.